In this video, you will learn how to use Zermatt, Automature's planning and reporting tool, to view the test results stored by Zug, Automature's automation engine. We are going to test a web application that creates a financial statement. Our objective is to verify that while creating a financial statement, the web application is doing the calculations correctly. First, we'll view the test plan to store the test results generated by Zug. I recommend that you watch the Zermatt videos to learn how to create a test plan and other planning features. To view the test plan, you need to browse through the product. In this case, it is PMIS, then the release, the project phase, and the test plans under it. The results generated by Zug are stored under the test cycle in the test plan. When we will run Zug, it will automatically create a test cycle under the test plan, so the count will be incremented by 1. If you browse to test cycle page, then you can see the details of execution. These are the date and time when the test was started and completed. This is the milliseconds to initialize the test case and milliseconds to complete. Now we'll run Zug and come back to this page to view the test results. To launch Zug from command line, you need to type runzug.bat. That is the batch file which contains the Zug's ZAR files details. The first argument is the input file, path, which contains the location of the test suite, an Excel file where the automated test cases are written. We'll view that file in a while. The second argument is the test plan ID, in this case 60, which specifies our release plan of PMIS product. The third argument is the topology set ID, in this case 2, which contains the details about the machines on which tests will be performed. And the last argument is verbose. When set, displays test details of the execution on the console. Now let's have a quick glance of the Excel file. A test case has several steps which are called molecules, and molecules have several steps that can be molecules or atoms. An atom can be a program written in any language as long as it can be run from the command line. Macros are like variable in any programming language, but the values cannot be changed at runtime. The molecules defined here are defined by the test case and the test case sheet. The Excel file contains the test suite written in Core, Automature's automation language, and has 5 worksheets. The config sheet, which contains the configuration details. The macro sheet contains the name of the macros and their corresponding values. The test case sheet contains the test cases. The molecule sheet contains the molecules used by the test cases. And the prototype sheet contains the prototypes of the molecules. This test case reads values from an XML file, and the values to be selected are specified in this macro, which is a multi-valued macro. Multi-valued macros can contain any number of values, so it contains 2 values. If you see the XML file, these are the 2 data sets that are selected for the test case. This test suite includes molecules from another Excel file which contains a number of reusable molecules. So you can create your own repository of molecules and use them to write many test suites. In this test suite, we have written only 1 test case and have specified 2 data sets in the XML file. So Zug will automatically create 2 test cases with different IDs and run them sequentially and store the results in the database. For more details regarding Core language, please view the Zug videos on our website. Now let's run Zug from the command line. First, it reads the XLS file that contains the test cases. and then tries to connect to the database. After that, it starts to launch the atoms. When atoms are launched, arguments sent to it are also shown on the console. On this page, it will enter the loan number and will click on the Add New button to create a new loan. Here, FS type, months and period, and headline will be filled simultaneously. If you look at the console, then you see that 3 atoms were launched simultaneously to perform the task. Here, the values for the 2 columns will be entered simultaneously. 2 atoms were launched simultaneously to perform the task. Now it is doing the verification, and for verification it has launched 3 atoms simultaneously. The verification is basically checking whether the sum done by the application is correct. If you see here, you will find audit financial statement was created by Automature and is listed right at the top. Now Zug will delete this entry and will try to run the test case again with a different set of values. So let's go to the test cycles page and see whether the results were stored or not. Here the test cycle is listed as 36. If we refresh the page, it becomes 37. Let's browse to the test cycles. We'll browse to the test cycle listed at the bottom of the page. To view the test results, we need to browse through the topology set. If you see on this page, 2 test cases are listed. The first one is pass and the second is still running, and the duration for the first is also shown. The second test case is shown as running because Zug is still running the second test case. So let's go back to the command prompt and see if Zug is still running the test case. So Zug is still running the test case. Now it is deleting the second financial statement. Now it will do the cleanup activities like logging out and closing the browser. Now if you look at the console, you'll see that Zug has listed the 2 test cases and their results, whether pass or not. In this case, pass for both the test cases with the duration. Now if we again refresh the results page, the second test case will be shown as pass with its duration. Let's have a quick glance of the dashboard. This is the test case quality dashboard that contains details about a particular test case. In this case, test 001, details like name of the test case, minimum time it took to run, maximum time, tags associated, if any, 37 number of cycles where this test case was executed, and 2 topologies where this test case was executed. and these are the variable values which were used to run this test case. Details of the last execution is also listed, the date and time, the status, execution time, and the mean deviation, and build if any. Details of the topologies are also listed, topology name, description, architecture, attributes. This graph shows the number of topologies on which the test case was run. In our case it's 2, so 2 topologies are listed. When run on the first topology set, it has no entries. That means every time it failed. When run on the second topology set, it varied a lot. So this is the execution time. There are a number of dashboards available. We'll view the product quality dashboard. Here you'll find details of the product. So if you see a particular product, then you'll find that how many requirements it has, how many extra requirements, critical requirements, so requirements overview, and then requirements coverage by product means how many requirements actually have at least one test case. Then requirement tested by criticality, normal requirements, extra requirement tested, critical requirement tested, requirements failing by criticality, and finally bugs outstanding by product. So these dashboards give you an overview of the product at any point of time. For further details, please visit our website automature.com.